Question 1, cool one. So press pause, write parts A and B down, and press play when you are ready. In this question, we're dealing with exact exam style questions on the core. They're slightly more complicated than back to basics. So let's look at this. Now, when we see this, we're looking at different terms, let's say numbers, x's, and y's. So let's first of all look at all the numbers over here. And all the numbers, let's call red. Okay, we'll put a red box underneath these. All the x's, we'll put a green, like we've done with all our videos. And the y's, we'll just put a black color over here. So these are three different terms, should we say, that are all different with respect to each other. So let's see what goes into 12 and 15. Let's deal with the numbers first. So the HCF of this is simply 3. Next, x squared and x, the green boxes. What goes into x squared and x? It's going to be x. And what goes into, well, there's imaginary 1 over here, 1, and y. Well, we can't do that because we haven't got enough information there. So let's create our brackets once we have our HCF outside over here. Remember, this is our HCF, what we've created on the outside. Let's just write that HCF if you do get confused. So step 1, HCF. Step 2, our bracket. Step 3, what goes inside this? Let's work backwards for this. So 3x times what gives you 12x squared. So it's 4x. 3x times what gives you 15xy. So this would be plus 5y. We don't put the x because that's irrelevant. So make sure you understand how we created that using the simple idea of the boxes. Let's underline this. So now we do part B. So part B, factorize 18x squared y cubed minus 12xy squared. That sounds really complicated, but let's break it down again with what we taught you just now. So all the numbers, let's put a red box here. The x's, we'll put a green box, and then all the y's, we'll put another colored box. Let's call it black in this case. Here we go. Let's do the same thing. 3 steps. HCF is number 1. So first, 18 and 12. What goes into those two numbers? 6. What goes into x squared and x? X. What goes into y cubed and y squared? This will be now y squared. Okay, just take note of that. That's quite tricky. In fact, most students put y, but actually the HCF of both these terms, it's actually going to be y squared. Second step, we'll put a big bracket around here. Third step, let's work backwards. Let's put a times here to help us understand this. Now 6x y squared times what gives us this over here? It'll be 3xy. Just work backwards and make sure we're correct with that. Minus, because of the minus over here. This one would be 2. Now the x will not be there because the x is already outside, and this would simply be, well, there wouldn't be any y over here, would there, because the y squared is over here. So this would be your final answer. In fact, let's just do this. It makes it a bit better, and that would be a final answer for how you'd create this. So make sure again you look through this video and look through this part B section, because these come up quite a lot in exam questions. There we go. Question 2, let's do it. So write this question down, press play when you are ready. Press pause, try this question, and press play when you are ready. So the first thing you've got to look for when you identify simplifying algebraic fractions is your denominator. You've got to look at your denominator first over here, okay, and think, are these denominators related or unrelated? Okay, there are only 2 types, related or unrelated. And what we mean by that is, do they go into each other, are they factors of each other, or are they totally unrelated? So these two, x and y, these are obviously unrelated. If these are unrelated, we're going to use a really good technique over here. We're going to use something called campfire method. X times y. Then we're going to be doing 2 times y, and then we're going to be doing 3 times x over here. Okay, campfire or camping method, whatever you want to call it. Okay, so let's do the first ones so far. So x times y was step 1. Okay, we'll call it step 1 over here. Step 1 was x, y, your denominator. That's what we have. Step 2 basically is doing 2 times y. So 2 times y is over here. Let's call it step 2, and that's simply 2y. Step 3 was 3 times x, or x times 3. Step 3 over here, and we're going to call that plus 3x. That is your final answer, as simple as that. So press pause, write this algebraic fraction down, simplify it the best you can, and press play when you are ready. So the first thing we do, we look at your denominators over here, and we think, are these related or unrelated? Now these are obviously related. They're both factors of each other. So what we do is a different technique from the last question. We're going to actually use the highest denominator we have over here. So we're going to be using x squared, okay? And when we say x squared, we're going to be using a big fraction as x squared, okay? Simply the highest one out of either one of them, okay? Remember, this is related. Now, what we're going to do is look at our first fraction over here and think, how do we get from x to x squared? We multiply it by x. Whatever you do with the bottom, you do with the top. This will be simply 1 times x on the top, x. Obviously over here, what do we do to get from x squared over here to this x squared over here? Well, it's times 1. So whatever you do to the bottom, you do to the top. You don't have to write times 1, but let's just do it anyway. It makes more sense. So this will be plus 2. And there you have it. This is a typical example of related denominators and using these small little brackets to help you. Press pause, write these 3 parts down, press play when you are ready. So here we're identifying a different kind of quadratic over here. More specifically, we're looking for a non-1 coefficient, which is 3 in this case, which gives it the name of advanced quadratic or advanced quad, as we'll call in this video over here. So any quadratic is going to be in this form over here, which we haven't mentioned before, ax squared plus bx plus c. And this will, you'll need this now because of the way we're going to look at the coefficients a and b and the integer c over here. So first step is step 1. Now step 1 is to define our quad box. So the quad box is used for basic and advanced quadratics. So you should know this by now. It's 2 numbers that multiply to get. Now it's 2 numbers that multiply to get a times c. Okay, so a times c over here, a times c. So a times c would be 3 times minus 4. So 3 times minus 4 is what we need to do over here, which is minus 12. Okay, and we want 2 numbers that add up to get the middle coefficient, which is going to be b, which actually is going to be over here, plus 4. So your quad box is set up nicely. Let's figure out the first row first. That's the technique. So the first row would be, let's think of this. Think of, 2 numbers and multiply to get minus 12 and add up to get 4. So we can think of 6 and 2. That will work straight away. Think of them until you get that 4 there. So it'll be obviously 6 and minus 2. 6 and minus 2. Let's insert this as well into here. So we're going to insert this 2. So step 1 is to insert these into your original quadratic. So we've got this as such. We've got 3x squared. Let's write this over here. 3x squared plus 6x minus 2x minus 4. Now look how these 2 numbers have been inserted into the quadratic, because you've got to agree that this is the same as this over here. The plus 4x is the plus 6x minus 2x. So step 2, let's do this. Step 2, we're going to now split and factorize. So split and factorize the whole thing. So we split this up. We'll write 3x squared plus 6x minus 2x minus 4. Split this up into such and factorize this. So 3x, we're going to factorize the first part. 3x, x plus 2 over here. And what we'll do, we'll leave x plus 2 over here as well. It's a little strategy. We're working backwards because these 2 brackets have to always be the same, x plus 2. This will be minus 2 over here. Step 3, so we're going to combine this. We're going to look at certain brackets over here. So 3x and the minus 2 will form one bracket. And let's say the x plus 2, which will always be the same, will form the second bracket over here. So your final answer would be 3x minus 2 and x plus 2 over here. See how we've taken the two brackets. This could mean the yellow one over here, and this one was the green one. Okay, so there's 3 steps, I'm more or less guaranteed to give you the answer for that. Take note of that, write them down into your math memory card, obviously. Let's do part B over here. So part B, how do we factorize? Well, how do we solve 3x squared plus 4x minus 4 equals 0? So let's get the answer for this and equate this to 0. So we've got 3x minus 2, x plus 2 equals 0. Okay, so because we don't do the whole thing again, we take the answer from part A, because these are the same, obviously, these expressions over here. We equate it to 0. Now what we do is split this in 2, and we make each one equal to 0 separately, so they both look like equations in their own right. So let's solve this. 3x equals 2, and x would equal 2 over 3. X would equal minus 2 over here. Oh, that would be your answer there. So those two are your 2 solutions of how we would solve a equation. You'd obviously just use part A, make each one equal to 0, and solve them separately as equations. Solve 6x squared minus 7x minus 3 equals 0. Let's do this question over here. Now this is straight away an equation, but we have to go around the long way, and we have to basically do it as such where we use the quad box, steps 1, 2, and 3. We can't get away with that. So let's do this really quickly over here. So we find 2 numbers that multiply to get the last 2 numbers. 6 times minus 3. All 2 numbers multiply to get minus 18, and add up to get the middle number, which is minus 7. So let's think of those. We could think of 3 and 6, 2 and 9. 2 and 9 seems good. So we'll do a minus 9 and 2. Okay, step 1 done. So step 2, obviously, well, let's insert these into here first of all before we do step 2. Let's insert these into 6x squared minus 9x plus 2x minus 3. Notice how this represents the b coefficient minus 7. So step 2, let's now split this in half. 6x squared minus 9x plus 2x minus 3. Let's half this over here and factorize the first bit. So we have 3x here, 2x minus 3. Let's write 2x minus 3 as a little trick, because they'll be the same brackets. And let's work back, well, what number goes over here to make that true? Well, it's just 1 or plus 1, that's right. So now we have the last step. We can combine them over here, and we can do it like this. Let's write these steps over here, by the way. Number 1, number 2, number 3. Okay, so we're going to simply create a first bracket, 3x plus 1. We got that by looking at, obviously, the numbers in front of this, 3x plus 1. And the second one is the bracket we see in either one of those, which is 2x minus 3. 2x minus 3, 2x minus 3. So let's write that over here, 2x minus 3. Okay, and we're done. That's how you factorize that one over here. Okay, so let's look now at part C. So part C is another type of quadratic. We call this half a quad over here. So half a quad is half a quad. We've called it that because we only have an x squared and an x, and this is one of the back to basic questions. So let's factorize this as normal. We'll take 4x outside. This will be 2x minus 3. Okay, now if there's an x, these little boxes help us. So there's an x outside. It doesn't matter if it's 4x or if it's x by itself. X equals 0 will be one solution. 2x minus 3. Well, you could do it like this if you wanted to. 2x minus 3 equals 0. 2x equals 3. X equals 3 over 2. So there we have it. X is 3 over 2, or x is 0. You're just about to see that, I think. Press pause, write this quadratic down, and press play when you're ready. So this question's all about solving a quadratic equation, and we know it's a quadratic because we have an x squared term, and a number over here, and it more importantly equals 0. Now we use quadratic formula when we can't solve a quadratic with the normal method of the quad box. So that's a little trick for this. And also another thing to look at to identify in the question is this word, three significant figures. That should automatically mean quadratic formula. So let's get straight into this and let's try to figure out the 3 steps to this. So step 1 is always to identify your A, B, and C. Now what do we mean by that? So step 1, 2, and 3, let's look at this. Now this can be written in ax squared plus bx plus c. It's the same concept, equals 0. A, B, and C are simply integers or whole numbers. So let's have a look at this and see what we can do with this. So step 1, A is equal to 1. This is managed to do 1 here. B is going to be equal to 2, and C is going to be equal to minus 1. So we've defined our 3, let's say, integers over here, A, B, and C. Step 2, let's get into this and plug this into the formula. Now you should know the formula inside out. This is not given in the formula booklet for Excel or AQA. CSEE might be a different matter. So B squared minus 4AC, the whole thing is over 2A. So let's plug this in. Now the trick is to always plug in the numbers under the square root first. So we're going to look at this and plug in the numbers over here because you want a positive number when you square root something. If you get a negative number, obviously you've gone wrong. So just bear with me. Let's plug this in. Now we can use the calculator straight away, the fraction button, to do this if you want to. The fraction button looks like this, this, and this on Casio's. But let's just go straight into this over here. So we've got minus B. B is 2, minus 2 plus minus square root. Now B is going to be 2 over here, so it's 2 squared. Now I always like putting a bracket over here, you'll see why for negatives, minus, and I always like putting a bracket around here as well, minus 4 times A times C. A is 1 and C is minus 1. So you've got that, and the whole thing is over 2A. So 2A, it's 2 times 1. 2 times 1 is simply going to be 2. Let's go a step further. So this will give us, let's do it over here in fact, minus 2 plus, let's do the square roots first. So 4, we have 4 minus, do everything in the bracket first, 4 times 1 times minus 1, minus 4 over here. Whole thing is over 2A. Or 2 rather. Let's go one step further. So this will all be done non-calculator up to here. You can get these questions to represent this in third form sometimes. They can be non-calculated questions. This is not obviously over here. So this would be 8 minus, 4 minus minus 4 would be 8. And the whole thing would be over 2. So this is one answer. So one answer, if you do this to 3 significant figures, we should get an answer of 0.414. That's your answer for the first bit. Now obviously we want a second solution as well. We have 2 solutions with any quadratic. So the second solution would actually be plugging in now the minus version of this, which is step 3. So step 3, simply go back on your calculator, or in this case I'll just show you over here. We'll do this, minus 2 minus root 8, and the whole thing can be over 2 over here. If we do this, we're going to get an answer of 2.41. So with 3 significant figures as well. So there you have it, 3 simple steps to do this, the 3 steps to define it. Let's do it one more time. So we look at this. Step 1, define A, B, and C. Step 2, plug in your values into your quadratic formula and also know which is the fraction button. And step 3, go back and sub in the other value, which is the negative version of that, and you should get 2 values to 3 significant figures for this. So press pause, write this question down, and press play when you're ready. And we're going to walk you through this let's do it question because it is quite tricky. So let's go for the answers over here. So this is called a compound shape, and obviously the question says the area of this shape is 40 centimeters squared. Show that 3x squared minus 2x minus 20 equals 0. So let's try to subsection this into 2 different shapes. It doesn't make a difference where it is. We'll do it over here, but we could well do it on the other side as well over here. Okay, we've chosen that. And obviously from your basic knowledge of this, let's call each one of these part A, part B. Okay, so A and B. So let's find out part A over here first. So we have 4x and we have x minus 2. That's part A, and part B is going to be x and 2x plus 4. Now we're going to expand this and we're going to make the whole thing equal to 40, because 40 is the area of these two shapes respectively, A being this one over here and B being this one over here. Now we won't do this in depth because of the space over here, but basically what you're going to end up with is something like this. 6x squared minus 4x equals 40. Okay, that's if you add these two together over here. This will therefore give us 6x squared minus 4x minus 40 equals 0. We can now take out the 3x squared minus 2x minus 20, and that agrees with what the question originally asked us. Remember, when we have the word show, it doesn't mean you've got to actually work this out. It means you've got to actually derive this. Okay, so 3x squared minus 2x minus 20 is the same thing as what we've figured out over here. Okay, we divided everything by 2. So in this way, you've shown this by just simply adding a and b and making this to a compound shape. So part B, let's solve this. So this, we're going to use our 3 steps and find out the answer for this. We won't go through all the 3 steps, but obviously A, B, and C are defined over here. Step 1, that is. Step 2, we use a quadratic formula, and we're going to plug in this over here into our calculator rather. Okay, remember, we want a nice whole positive integer underneath the square root sign. We should end up with this. Let's plug it into your formula button, which should look like something like that, and we're going to end up with 2 answers over here, 2.94, or we're going to get minus 2.27. So those are our 2 answers over here, 2.94 and minus 2.27. So guess which one we have to use. Obviously this is a real life example of let's say floor space or something like that, so we have to use the positive answer. 2.94 is what we want to find out. So 2.94 is the final answer. So part C, work out the shortest side. This takes a bit of common sense. What looks the shortest? Obviously this one over here would be the shortest with a negative sign. 2.94 take away 2 would be 0.94. This is not the scale at all, but that would be the answer for this part. So press pause, write this algebraic equation down, and press play when you are ready. So in this case, we are looking at a 3-step process over here, and during this topic again, we will look at these 3 steps which will help you during this topic. So the first step is to simplify this left algebraic expression over here. So let's look back at our notes and think, look at our denominators. So our denominators over here look like 2 and x plus 3. So these are unrelated. So unrelated means we need to use something called the camping method. You've guessed it. So 3 steps, steps 1, step 2, and step 3 over here. So step 1, let's just write this over here so we don't forget. So step 1, we're going to basically simplify the expression. So we have as a denominator 2x plus 3, and on the numerator, if we do this over here, we're going to get step 2, which is x times x plus 3. So we'll write this step by step, x and x plus 3 over here, and this will be minus 2 times 2, which is 4. So this will simply be x squared plus 3x minus 4, and we're going to put the whole thing over the same denominator, which is 2 open brackets x plus 3. So this doesn't simplify any further. So we've done the step 1 by simplifying the algebraic expression, because all we've done really is just look at this first bit on the left hand side, simply ignored 4. So step 2, we're going to now do something else, and step 2 we're going to basically introduce whatever's on the right hand side. So step 2, let's say we're going to introduce the equals sign over here, and we're going to use cross multiplication. Perhaps this symbol should signify cross multiplication. Okay, so we're going to apply this. So let's see what we have in step 1. We have x squared plus 3x minus 4. The whole thing is over 2x. We're going to write the whole thing this time. We'll see why in a minute. 2x plus 6, and this whole thing equals 4. So this allows us now to cross multiply, because any number can be written with a 1 underneath. So this times this will equal this times this. So let's make that a bit clearer over here. So we're going to say that this times this will equal this times this, okay, because two fractions equal each other. So we end up with this. We end up with x squared plus 3x minus 4, and this equals 4 times 2x plus 6, which in turn would be x squared plus 3x minus 4 equals 8x plus 24. So let's try to get all the x's, or quadratic rather. So we have x squared minus 5x, and we've got minus 28 equals 0. So we have a quadratic equation over here. So let's do step 3. So step 3 is to simply solve this, okay? The last bit of algebraic equations. Let's solve this over here. So let's use a quad box. So what two numbers multiply to get minus 28, add up to get minus 5? 14, 2, we have 7 and 4. We can't do it. So basically we use our backup formula, the quadratic formula. Let's define A, B, and C. A is 1, B is going to be minus 5, and C is going to be minus 28. Let's plug this in. So we have minus 5. So we have plus 5 plus the square root of minus 25 squared, 4 times 1 times minus 28 over here. And the whole thing we're going to write over 2 times 1 in this case. So 2 times 1 is simply going to be 2. Okay, let's simplify this a bit further. So we're going to get 5 plus, if we do this all together, sorry, this should just be 5 minus 5 actually over here. My mistake, sorry about that, because the answer actually is going to be, there we go, 25. So we end up with 25 over here. 25 minus, and this will be 4 times 1 times minus 28 minus 112, and the whole thing over 2. So if we do this, we're going to get 5 plus root 137 all over 2, which would give us an answer of 8.35. Okay, if we have the positive version. If we were to do the negative version, we simply put a minus here. We won't do that because we don't have enough space, but we'll write the answer minus 3.35. That is simply 5 minus 137 over 2. So perhaps I should do both of these to signify this. The positive version, negative version. So these are our answers for this question over here. So quite tricky, but the 3 steps, we really have to understand how to do these 3 steps if we want to understand algebraic, solving algebraic equations over here. So there are your 2 answers for this. So press pause, write part A and B down, and press play when you are ready. So write x squared minus 3x minus 2 in the form x plus p squared plus q. So again, this is complete the square over here. We need to find out what p and q are. So let's do what we did in the original question. Let's first of all halve this b coefficient. So let's make it x minus 3 over 2 squared. Notice how we are using a top heavy fraction over here, not a decimal. You'll see why in a minute. Now what we do, we take away this number squared. Now 3 over 2 squared is much easier to square, obviously, a fraction than the decimal. That's why we do this. So that will be 9 over 4, and then we're going to simply take away the number we see in the original equation, which is minus 2. So let's sort out the last bit because we want to make that look a bit easier. So this bit over here, we're going to make it into like one whole fraction. So minus 9 over 4 minus 2 over 1. So this will simply be, we can make this 4 over here. We can make this minus 9 and minus 8 from taking away fractions. Minus 17 over 4. So our final answer would be this. The final answer would be x minus 3 over 2 squared minus 17 over 4. So we've got 2 answers over here. We've got the p number, and we've got the Q number over here, P and Q. Let's define both of those over here. So P equals minus 3 over 2 and Q equals minus 17 over 4. So let's look at part B. Now part B is a bit more complex. It's asking us to find the roots of the equation. The roots simply mean the solutions, the answers of finding x basically. So let's use our answer for part A and let's see what we can do to find the roots of x, two values of x, because obviously it's an x squared function over here. So we've got this. So next step, let's make it equal to 0, because if y equals 0, that's why the roots always happen with y equals 0. It crosses over the x-axis. So let's get this minus 17 over 4 to the other side. Let's do it like this. X minus 3 over 2 squared equals 17 over 4. Now let's square root both sides. So x minus 3 over 2, we'll get rid of the brackets, equals the square root of 17 over 4. We'll put a plus and a minus because you can have two positives times positives to give you this, or negatives and negatives to give you that. And now we're going to do the final value of x. X equals, let's say, the positive version, root 17. Let's say over 2 in this case, because we can square root the denominator over here. Plus 3 over 2. That's one solution. And the other solution would be this. X equals root 17 over 2 again. But this would be now the minus version, remember, because of the minus version over here, plus 3 over 2. We can simplify both of these. This would be, obviously, if you make this to a nice number, a big denominator over here, 2. It'll be 3 minus root 17, if you can see that, okay? And this would simplify to be a big denominator over here, and this would be 3 plus root 7. So those are your two values of x that satisfy this equation. Well, obviously when y is 0, you have two roots. First root being this one over here, and the second root being this one over here. Question 10, core 10 gold quadratic equations. Press pause, write this question down, press play when you have finished. So let's find two consecutive even numbers whose product is 168. So product means multiply or times. In this case, consecutive means one after the other. Okay, so let's have a look at this. Now, even number, you should know that even numbers can be represented in the form of 2n. So if you think about it, the product of two consecutive even numbers, it's going to be 2n multiplied by 2n add 2. Y add 2, that's the next even number after that. Okay, and this should give us 168. It's always good to get the setup correct. This is your setup initially. Now this is the same thing in algebra as 2n. 2n plus 2 equals 168. Let's multiply this bracket over here as such. So we're going to get now 4n squared plus 4n equals 168. Take away the 168, 4n squared plus 4n minus 168 equals 0. Let's divide the whole thing by 4. So we're going to get this n squared plus n minus 42 over here. Ignore the 4 outside. We're going to do the quad box on this this equation over here, n squared plus n minus 4. So two numbers and multiply to get minus 42. Two numbers add up to get 1. One of these numbers in our quad box. So let's have a look at this over here. So if you look at this, minus 42 would give us minus 6 and 7, and minus 6 and 7 over here. So it'll be n minus 6, n plus 7 equals 0. Ignore the 4 outside. So n will equal 6 or n equal minus 7. Therefore, it doesn't make sense having n equals minus 7, n equals 6. That's your answer. We can even test it by doing it over here. So if n equals 6, we can say 6 times 2, okay, that's 2m, that's the first one, and this will be 2n plus 2, which is 8 times 2. So basically 12 times 14 would give you 168. So the answer would be 12 and 14. These are your two numbers, even numbers, we've plugged into the original equation via quadratic to give us your final answers over here. 12 and 14 are your two even numbers. Question 11, core 11 gold quadratic equations. Let's press pause, write this question down, press play when you have finished. So the sum of the squares of two consecutive positive integers or numbers is 41. Find the numbers. So these are keywords over here. First of all, sum means to add, square means you square two numbers consecutive one after each other. So first of all, let's define these two numbers. So let's call one number, let's call the lowest number n, okay? And the number after that would naturally be called n plus 1, okay? So the sum of the squares of two consecutive numbers. Now, let's add these together and square them as well. So we do this. We're doing n squared plus n plus 1 squared, okay? We're using the idea of sum in the middle here, plus, and squaring as the word square. Okay, this equals 41. Let's just basically expand this. So n squared plus n plus 1 equals 41. So n squared plus, if we do the crab claw are these 4 steps, 1, 2, 3, 4, looks like a crab. We get n squared plus n plus 1 equals 41. So therefore this is 2n squared, because n squared plus n squared is 2n squared, plus 2n, because the 2 n's are 2n, plus 1 equals 41. Let's take away the 41 on the other side. Why? We want to make a quadratic. These type of questions will always involve a quadratic, equals 0. So let's divide it by 2. We have an even number of 2, so to take the 2 out of the whole thing, we get that. Let's do quad box now on this bit over here with the two numbers that multiply to get minus 20 and add up to get 1. Okay, this is the quad box. So let's think of these numbers. They will be 5 and minus 4, 5 and minus 4. Okay, so if we got this over here, let's now look at this. So we got basically n plus 5 and n minus 4, equaling 0. So n will equal minus 5 or n will equal 4. So these are your two numbers, but n would equal 4 quite naturally. If n equals 4, let's plug it back into the original. Okay, so we got 4 squared plus 4 plus 1 squared, which is going to be 4 squared plus 5 squared, which is going to be 16 plus 25, 41. And this will work over here. Question 12, core 12 gold quadratic equations. Press pause. Let's write this question down on quadratics. A bit of a word question. Press play when you have finished. Okay, so Sam is 5 years younger than Joanne, and in 2 years' time to come, the product of the ages will be 1, 2, 6. Years formulate a quadratic equation to represent this information to present the ages. Okay, so this question is all about finding a base, and the base is the, let's say, the person who we can actually, where all the ages come from in terms of the actual base or beginning of this. If that makes sense. So basically, the base over here is Joanne, because Sam comes from Joanne, you see? So I'm going to call J equals X, and Sam will equal X minus 5. So very important, the base is Joanne over here. Okay, now in 2 years' time, the product of the ages will be 1 to 6. So in 2 years' time, we're going to add 2 years to this, which means Joanne would now be X plus 2 years. Okay, and Sam would be X minus 5 plus 2, which is actually X minus 3. So this is the key information we need to work on over here, okay? Because this is what we'll be looking at to formulate the equation. So we can say that X plus 2, the product of these two ages, multiplied by X minus 3 will equal 1 to 6. Let's do the crab claw on this over here. So we're going to get these 4 things multiplied together. So we'll get X squared plus, if I do the 2 things together over here, minus X, minus X, minus 6 equals 1 to 6. X squared minus X minus 132 equals 0. Let's now do the quad box on this. Okay, so we've formulated a quadratic equation. Let's do the quad box and find out X. The two numbers are multiplied to get minus 132, add up to get minus 1. So quad box minus 132, adding up to get minus 1. That's the quad box. If you fiddle around with these numbers, we should get these two numbers over here. We should get minus 12 and 11. Okay, minus 12 and 11. So if you do this on the quad box, we're going to get x minus 12, x plus 11 equals 0. So therefore x is equal 12 or x equal minus 11. This doesn't make sense over here, so the final answer will definitely be x equals 12. So let's put this back into our original equation, see if it works. X equals 12. So the base was x equals 12. So if you look at this, x equals 12 would be over here, okay, because Joanne was x. X plus 2, or 12 plus 2 is 14, simply goes in here, okay. So the base, let's write as 14 first of all. And Sam is 5 years younger, or you can plug 12 back into here. 12 minus 3, which is 9, and that should be your answer. Let's test this over here. We can do Joanne times Sam, so 14 times 9. This would give us a 126. It's a good test to make sure it works. So the answers are those ages respect. Platinum. Let's press pause. Let's write this final question down. See if we do this. Press play when you're ready. The two numbers differ by 4. Okay, differ means difference. If the sum of their reciprocals is 2/3, find these numbers. Reciprocal means 1 over something. Okay, so let's have a quick look at this. Let's call this x and y. So two numbers. Let's call it, let's say, x take away y equals 4. That's the first thing we gather from the first sentence over here. Okay, because two numbers differ by 4. The difference is 4, and x and y are two numbers. The two numbers we want to find out. The sum of their reciprocals is 2/3. So reciprocals means 1 over this plus 1 over this equals 1 over y equals 2/3. Okay, equation 1, equation 2. Let's go further and create equation 3 because we want to ultimately substitute one variable into another. So we can call, let's say, x, the subject over here, x equals a y plus 4. So we're going to be dealing only with two things now, equation 2 and equation 3. Let's substitute now this x here into the this x over here. I can show you this one, x into this equation over number 2. Okay, so wherever we see x, we plug in y plus 4. So 1 over y plus 4 plus 1 over y equals 2/3. So this is the same as saying now, you find a common denominator, y plus 4 over here, and this will be y plus 4 equals 2/3. It's the same thing as saying 2y plus 4 over y squared plus 4y equals 2 over 3. Okay, it's just algebraic fractions basically. Adding them up using algebraic fractions. Let's carry on this side over here. So now we can do this. We can cross multiply. We can say to ourselves, this times this can equal this times this. All right, so we've got basically 2y plus 4 times 3 will equal 2y squared plus 4y. Let's multiply this out the half crab claw. So if we do this, we simply do 3 times 2y, 3 times 4, 2 times y squared, and 2 times 4. Sorry, 2 times 4y here. So we get 6y plus 12 equals 2y squared plus 8y. This looks familiar. Let's get this as a quadratic. So if we take these 6y and the 12 to the other side, we're going to get this 2y squared plus 2y minus 12, okay, equals 0. Okay, let's divide the whole thing by 2. So we're going to get this 2 outside, and y squared plus y, take away 6 equals 0. Let's form the quad box now. Again, let's ignore the ignore this 2 outside. So we want two numbers to multiply to get minus 6, add up to get 1. Okay, so these two numbers, let's figure this out. Very easy, in fact, this to do. It's going to be 3 and minus 2. Let's formulate the last bit of this. So we're going to get basically x plus 3 and x minus 2 equals 0. Therefore, x would equal minus 3, x would equal 2. Okay, obviously, let's take this positive integer over here of x equals 2. That's our final answer for this. So let's sub this in to find the corresponding y value. If we do this, this would go back into equation number 3. So in fact, all of this should have been y. The last two stages, we made a mistake over here. This should have been y over here. I don't want to confuse you. This should have been y and y and y as well. Okay, so if this is y equals 2, so if y equals 2, this would be now x would equal 2 plus 4, which would equal 6. So finally, our final answers are going to be y equals 2 and x equals 6. You can test them by doing it into equation 2. It'll work for either one of them. That's your answer for this platinum question over here. So press pause, write parts A and B down, press play when you are ready. So write 2x squared minus 10x plus 3 in the form of this. So obviously the thing that is new to you is this 2 coefficient in front of the x squared term, okay? We need to find out the value of A. So let's deal with it. Well, there are a couple of ways of dealing with it. Let's do the most simplest way possible. Let's divide first of all everything, well, not everything, just the B coefficient by 2. We're going to create a square bracket over here, x squared minus 5x, okay, and put a plus 3. So this way we're dealing only with the first, let's say 2/3 of this, okay, we're only dealing with that. We're not going to look at anything else. The 3 we'll bring in at the end. Let's now complete the square on this first bit. So we can have 2 square bracket, curly bracket, complete the square on this, minus 5 over 2, curly bracket. And let's take away obviously this number squared, 25 over 4, okay? And now let's put the square bracket and we'll put plus 3. Again, we're only looking at the, let's say, this bit over here, okay? What concerns us over here? Ignore the 3 from the outside. So now let's basically, again, do what we do before in a normal complete square scenario. Let's ignore the 2 outside. Let's basically now multiply everything by 2 because of the 2 over here. Let's get rid of the square brackets. So we're going to multiply this by 2 over here. Let's show you how we do this. Multiply this by 2 and also multiply this by 2 as well. So we get 2 curly brackets x minus 5 over 2 squared, okay, minus 50 over 4. The way we got 50 was obviously doing 2 over 1 times 25 over 4 to give you this number. And what we're going to do now is to add the 3 over here. So the square brackets go. Now we want to obviously get a nice number after this. We want to get a nice number like we did before to simplify these two. So we're going to look at this and say to ourselves minus 50 over 4 plus 3 over 1. So this should give us a big common denominator of 4 minus 50 plus 12, which is minus 38 over 4. We'll simply link it on now to what we had over here before. So this will give us a nice final answer of x minus 5 over 2 squared minus 38 over 4. So that would be the final answer for part A of how we would deal with something with a non-1 value for the x term. Now turning points are pretty simple. It doesn't really affect anything over here. The turning points would be, if we look at this, how do we make this whole thing equal 0 over here? We want to make this whole thing equal 0. Okay, so that 2 wouldn't really affect it. If you look at it like this, it's the same concept as before. The trick is to make this number the opposite of minus 5 over 2. So it's 5 over 2, comma, and the leftover number is minus 38 over 4. So that would be your turning point over there.